Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.
Hello, my name is Michael Keenan, and today I'm going to be doing an example of a question involving polynomial inequalities from Unit 2 of Grade 12 Advanced Functions called Polynomial Equations and Inequalities. This question can be found in your Nelson 12U Advanced Functions textbook on page 227, number 10. The question is as follows. Determine an expression for f of x in which f of x is a quartic function. F of x is greater than 0 when x is greater than -2 and less than 1. F of x is less than 0 when x is less than -2 or greater than 1. F of x has a double root when x equals to 3, and f at -1 equals 96. So the first thing you should do when you look at the question is realize that the greater than and less than signs relate back to Unit 2 of the course, Polynomial Equations and Inequalities. So what I've done is highlight the key components that the question gives us. The next thing I'm going to do is come up with a plan that I will follow step by step in order to solve this problem. Basically, I'm going to make this question as simple as I can by only dealing with one key element of the question at a time. Also, I'm going to sketch a graph of the function before I write my expression to help me out visually. First, I'll derive as much information as I can from the fact that f of x is a quartic function. The next thing I'll do is I will sketch a graph of when f of x is greater than 0, so between -2 and 1. After that, I will add to that same graph for when f of x is less than 0, so from -infinity to -2 and from 1 to infinity. I will continue to add to the sketch of the graph for when f of x has a double root at x equals 3 and when f at -1 equals 96. So I know not everyone is an audio learner, myself included. So I've written out a copy of the steps I'm going to follow to solve this problem so that you can follow along. They will remain on the screen for the entirety of this video. Step 1. So we're going to derive as much information as we can from the fact that this function is a quartic function. We know that quart means 4, so we can say that this function has a degree of 4, meaning that the highest exponent x can have in this function is 4. Also, since 4 is an even number, we can say that this is an even degree function, which means it will follow the same end behaviors as a quadratic function. Those end behaviors are as x approaches infinity, y also approaches infinity. And as x approaches -infinity, y approaches infinity. We also know that a quartic function can have a certain number of zeros, either 0, 1, 2, 3, or even 4. Also, a quartic function can have either 1 or 3 turning points. So, step 2, I will sketch a function for when f of x is greater than 0, so when x is greater than -2 and less than 1. But first, I want to talk about how I'm going to do that. So since we know that x is greater than 0, which means it's positive, between the intervals of -2 and +1, that means the function is positive. So that means that it is above the x-axis. The x-axis, if you didn't know, is the horizontal line, and the y-axis is the vertical line. So below I have a graph of what that looks like so far. It's only sketched, so the only two real points are the -2 and the 1. Notice how the end behaviors also follow the same end behaviors as a negative quadratic function. So as x goes to -infinity, y goes to -infinity, and as x goes to infinity, y goes to -infinity. Step 2, so I'm going to add to the graph. Okay, so since we know that when x is less than -2 or greater than +1, we can say that the function will be negative. That means that the function will be below the x-axis. You may not see it right away, but because of this information, we have just discovered our first two zeros of the function, also known as roots. Basically, a zero or a root of a function is any number that makes the equation of the function equal to 0. They are also where the function crosses the x-axis. So in this case, because the function crosses the x-axis at -2 and at +1, the zeros of the function are -2 and +1. Step 4. Add to the sketch of the graph so that f of x has a double root when x equals 3. So with -2 and +1, both of them were single roots. This basically means that their factor is to the exponent 1. So a double root, as you can probably guess, means that the factor has an exponent to the 2. This will create what is called a bounce, meaning that when the function approaches the x-axis, it just touches the x-axis, doesn't cross straight through, and it'll bounce back down. So as I mentioned before, this factor would be written to the exponent 2, meaning that it bounces and doesn't cross through the x-axis. Step 5 is really simple. They give you the coordinate -1 and 96, which means that the x value of -1 will have a y value of 96. So all you have to do in this step is plot that on your graph. So we've created a graph for a function and everything's looking pretty good. We still haven't answered the question, and the question wanted us to write an expression on a graph. So what we're going to do is put the information we've gathered from the graph into factored form. So that would look like f of x is equal to a x plus 2 x minus 1. So if you noticed in the last step, there was a variable of a in front of the rest of the expression. So we can't just leave that with no value. So luckily we were given a coordinate -1 and 96. So what we're going to do is for every value of x, we're going to replace that with -1, and we're going to replace the value of y with 96. So after that, it's just basic math. -1 plus 2 is 1. -1 minus 1 is -2. -1 minus 3 is -4. And -4 squared is 16. So 1 times -2 is -2. And -2 times 16 is -32. So the last thing you have to do is divide both sides by -32 to get the value of a. And 96 divided by -32 is -3. So your a value is -3. And that's it. You're done. Your final answer you're left with is f of x equals -3 to the x plus 2 times x minus 1 times x minus 3 squared. One career where someone would need to be able to solve polynomial inequalities and equations would be a math teacher. Math teachers need to be able to know how to solve these things because they need to adequately teach students how to do this in a way that they will most likely be able to understand and retain. I hope you found this video helpful.